Okay, instead of plugging these things in here to start with, I'm just going to write out the equation because it's much simpler not to have to carry the actual quantities through. Just use symbols, get the general solution, then plug in your quantities and see what you have. Okay? So, we make the usual assumption that Q is some multiple of e to the lambda t. We get our characteristic equation. We write out the characteristic equation. Then we divide through by L, so we have a coefficient 1 on the lambda, although we could have left the L there if we wanted. Okay? Matter of taste. And we get lambda from the quadratic formula, and I'm not going to read it to you, I just wrote it down. Then I factor an L squared out of the denominator here, and then take the square root of that, giving me an L in the denominator underneath the square root. Okay? And we can easily check, divide this expression by L squared, and we get back to this expression. So this seems to be correct. And of course, we have the negative R over 2L from here. And this is a 2, not an L. I was going blind there. That looks so much like an L that I started thinking I'd made a mistake. Although things check out pretty well here, so I kind of believe what I've got. Okay? Then I factor out an R squared here, giving me an R out in front, so I have an R over 2L. And inside I've got 1 minus 4L over R squared C. If I multiply this through by R squared again, I get back to this, proves that step. Then I don't like the looks of it, so I check the units. Okay? And the units work out. Okay? Units of L, volts seconds per amp. Units of reciprocal capacitance, volts per coulomb. Units of resistance are volts per amp. Reciprocal resistance would be amps per volt, and it's squared, so we get this. So we have an amp to take care of that amp. Our volts clearly take care of themselves. So we end up with an amp second per coulomb, but a coulomb per second is an amp. So we have amps over amps. So the units, this is unitless, as it had better be if it's going to be compatible with that 1. And of course we have a 1 here. All these have to be just pure numbers. Well, the units work out, and the units of R over L are as they are, so it looks like maybe we're going to be okay here. Well, there's something about this that just bothers me. Okay, well, in any case, what do we get now if we plug in R, L, and C? What's this tell us?